Hi and welcome to another MyMaths walkthrough. This is 329 Sine and Cosine Graphs, grades 8 and 9. Right, I thought it would be useful to have a look at where the graph comes from before we actually start off, because I remember when I saw this, which was way past my GCSE time, I was just amazed that I wasn't shown it earlier. So I thought I'd show you how the cosine graph and the sine graph and then the cosine graph comes together. What happens is you've got this circle, and the circle has got a radius of 1, that's why it goes up to 1, so it's, that's what the circle is. What you do is you start with your radius down the bottom here, pointing there. So when you haven't travelled anything, so a zero angle, you at this point, so zero angle is at zero height, and it's the height that you travel at. And then what happens is you travel around the circle, and you go on around the circle this way around, and you're marking off the height of the circle, the height of the radius at every point. So if I go 45 degrees, for example, so up here, I'm at this point here, so 45 degrees is going to be about there, put across, because it's nasty. When I go to 90 degrees, so I'm straight up the top, so I'm at the top of the circle, so it's there. When I travel 135 degrees, which is another 45 degrees off, I'm at the same height as I was when I was at 45, so you've got to imagine that. I can't actually see it, but it would be the same height as that one. When I'm at 180 degrees, I'm flat again. And then when I'm down at this one down here, it's like the opposite of that one. So 180, so it's going to be there, and I've got 2 and a bit up, haven't I? So I'm at that point. 270 means you've travelled all the way around to here, so you're travelling in an anti-clockwise direction. So you travel to 270, you're there. So you're at the bottom of the circle, so that's here. And then you just put the others on as you wrap around. When you go 360, you're back at the top again. And that can actually go on forever. What that does, it gives you this graph here where it curves round. You've got to try to get a curve on it. I'm not very good at drawing. And curve it round, and there's your graph. What you've got to realise is that when you are at any particular angle, so if I'm at this angle at 45 degrees, that's exactly the same height as it was when it's 135 degrees. Now if I do the sine of 45, I will get 0.707, and if I do the sine of 135 on the calculator, let's have a look. So sine of 45, oops, that was 14, 45 is 707, and the sine of 135 is 707 as well, because it's at the same height, exactly the same height. Now when you do the inverse sine of that, so if I do shift and inverse sine, that's only going to tell me one answer, so it's only going to tell me the 45, because it's just telling me the first one it comes to on the graph. And what I've got to realise is that it's going to be the same height here, it repeats here. It'll actually keep repeating forever, because this can go up and down and up and down and up and down, just depending on which you want to spin. So the next one will be 405, would be the same. So if I do the sine of 405, let's have a look, I should get, yep, 707 again, because they're all at the same height, okay, and your calculator is just going to tell you the first one. You can also go backwards into negative angles, and you would find out where that one is. I think it's minus 225. Let's have a look. So sine of minus 225. Yep, that's the one. Is 707 again, because that would be, you've gone 180, you've come back. Sorry, you've gone 90, minus 90, you've gone 180, and then you're back to 225. Minus 225 is the same height. So they're all the same height, but the calculator just tells you the first one. If I look at a cosine graph, so the cosine graph, slightly different to the sine graph in that you start with the thing pointing at the top. Okay, so when you've gone no degrees, you're at the top. When you've gone 45 degrees, so I'm over here at 45 degrees, so 45 is going to be just there. And then when I've travelled 90 degrees, again we're travelling anti-clockwise, we're at this point here, so we're there. And then at, what's that, 135, we've travelled down to here. And again, this just keeps wrapping round. And you can do all the other angles if you want to do a really precise one. But because, just for speed, just going to do those ones. And they end up with this sine graph, which looks a little bit like this thing. Okay, so there's the, sorry, this is the cosine graph, or cosine wave, or whatever you want to call it, and it's a bit like this one, but moved across a little bit, and there is a transformation that you can talk about, moves the graphs around, but it's the same idea. So if I look at this angle here, which is 45 degrees, and then that's at the same height as this one all the way over here, so this is at 315 degrees over here, so cosine of 45 should be the same as cosine of 315. Let's have a look. So cos 45 is that 707, and I've got cos of what was it? It was 315. Should be 707 again. Yep, 707 again. So that works at any angle, right? So if I pick an angle of let's go on this one. If I pick this angle, I'll just pick a random angle. Let's say I pick 80 degrees, right? So 80 degrees, let's say 80 degrees is about here. So 80 degrees is going to be there. Okay, so whatever that is, let's have a look. Cos of 80 equals 0.713 apparently. So that's a height of 0.713. 173. Now if I come across the graph, it's going to be this point here, and the nice thing about the graph, it's symmetrical. So what I can see now is the 80 degrees was 10 before the 90, so it's going to be 10 after the 270. So that's going to be a 280 in fact. So cos of 280 should be that number, 0.713. So look, cos of 280, is it? 0.713, that's right. Okay, so you can do that with any angle. So if I look at any random angle on this thing now, so if I say, I don't know, let's go for the angle of 57 degrees. So 57 degrees in here somewhere. So let's say it's there. Whoops, can't see it. Let's say 57 degrees is there. So it goes up, hits the graph here. What's that one? So sine of 57 equals 0.838. So that's going to go to there. So that's 0.838. And then that's going to be the same as that one there, whatever angle that is. Now, what you're looking at for the symmetry is if I go from 90 to there, it's going to be the same distance from that one. So 90 down from that one is, what's that, 33. So 33 upwards from that one is 123. So let's see for 123. Sine of 123, I'm looking for this answer. Sine of 123 is 0.838 again. So it does in fact work. And the graph is really nice to look at because you can actually see what's going on there. Okay. So that's the whole idea of the sine and the cosine graph. Now, if I look at the MyMaths questions now, and this is where I have to minimize that camera so I can actually see what I'm talking about. So all the MyMaths questions are working like this one. So my first question says, if the sine of x equals 0.41, if I get the calculator, I can figure out x is equal to, and I just inverse sine it, so shift sine minus 1 of 0.41, and it's got that 24.2, which is 24 degrees, which is what the calculator, what's what the MyMaths is telling me on my computer screen. Now I've got to find the other one, right? That's equal to the same thing. So if I look at where 24 degrees is, so 24 degrees is going to be down here somewhere. Now what I can say for the 24 degrees mark, it's going to hit here, but it's also going to be there as well. Now 24 is 24 after the 0, so it's 24 back from 180. So I'm thinking that's going to be 156 there. So that's 156. Okay. So I'm going to put x equals 156 for that one. Let's do a cos one. I'm not going to do them all because I'm just looking at the time on the clock, so the explanation bit. For the cos one, I've got cos x equals, I'll go for a negative one, whatever, not minus 0.03. Okay, so if I do the inverse cos, so what am I going to do? I'm going to go shift cos minus 1 of minus 0.03, and I've got 91.7, so I guess that's going to say 92. Yep, 92 degrees. So if I look on the picture for the cos, so for 92 degrees is going to be about here. So it's also going to be all the way over here, and that's 2 degrees after the 90, so it'll be 2 degrees before the 270. There's 270s there, so that's going to be 268. So x is going to equal 268. So if I now just do the cos of 268, let's have a look, cos of 268, I should get minus 0.03, which is what that one's saying, and it's been rounded, 0.034 rounds to x equals 268. And that's basically all you're doing on the first exercise. if I look at the second exercise, what have we got? Alright, so it's just saying the sine of, so it's doing the work itself. So the first question for me says sine x equals 0.49, and it's not telling you what the value is. So all I'm going to do in the calculator, if I just jump back on the camera so I can see, all I'm going to do here is do sine inverse sine of 0.49 to figure out what the angle is. So you've got 29 degrees there. X equals 29, and it says, what does it say, to the nearest degree? Yep, so 29 is alright, 29.3. So then I'll look at the graph and I say, well, on my graph 29 will be, let's say 29 is there, so we come up, we hit the graph, we drop across, hit the graph, drop down, so it's 29 away from 0, so 29 back from 180 is 151, I think. So x is going to be 29, or it's going to be equal to 151, I'm thinking. And then the numbers I'd put in. And that's it. The rest of the exercise is just exactly the same sort of idea. Okay. So the whole thing is, looking at the graph, because of the symmetry, you can either go from the 90 or you can go from the 0 and 180 mark on that one. And on this one, I'd probably be going from the 90 and the 270 marks for the symmetry part. That's it. Go and have a go at the MyMaths task. Hope that helps.